Do it right now. So I'm starting to stream, as you can see here, and now it's going. I don't know if you get a live notification of this specific stream. I'm seeing if you want, like I said, just go to Google and hit YouTube, search for Anthony Truss. You should be able to see the live link that I'm broadcasting now. Otherwise, like I said, watch and you'll have this video collected for you and you can kind of refer to it. So once again, we want to create the switch, not the switch, but the fastener bracket. And the fastener bracket document I just gave you in physical form, there's a link to it in the description. And so you can click on it in a digital link. It looks like I have one person watching right now. I don't know who it is. Looks like a couple people have found it. Okay, good, you found it. Awesome. So I'm going to create a new document because I already made it here. But one of the things I want to point out in my sketch, oh, wrong one, my sketch 2, this is where most of the work is done. And this might look a little intimidating for on first glance, but we're going to kind of go through this and kind of understand how we keep geometry symmetrical and how we maintain tangencies to arcs and how we're able to trim. You can see that there's a tangent symbol right here, right? And so how did I get those? This is the first time you've been kind of introduced to that in this class. I want to make sure that obviously you aren't ill-prepared. But that's where the bulk of the work is done, okay? So understanding the concept of radius being half of the diameter is important. Understanding the concept of when it says drill a hole, it's specifically mentioning a diameter measurement because that's how drill bits are measured. And then just dividing and finding the middles of numbers is pretty much the key to this. So I'm going to create a new document. I'll call this Fastener Bracket Demo YT for YouTube. So I'm going to kind of think of this as creating it sitting on top of a table. So my first sketch is going to be the top plane. That's where the majority of everything is going to go. And so at this point, what I want to do is square up my top plane. And I just click the top cube in the upper right-hand corner. And it just kind of squares it so I can kind of only focus two-dimensionally at this point. I have an origin, which is very helpful. Okay, and so since this is a symmetrical part in both directions, the X and the Y, I'm going to set up a construction line matrix, if you want to think of it as, to kind of guide me, my midpoints. So I'm just going to press L on the keyboard or the line tool, and from my origin down through, I'm going to create a line, and then I'm also going to create a line horizontally. So I kind of have an X, or a plus, not an X. Now I'm going to right click on them and go down to construction and make them construction lines. So I'm really just setting up my workspace. So at this point I have reference lines. That's all they are, right? We talked about dot dash lines can be either used as center lines, lines of symmetry, or construction lines, and it's just a simple right click, okay? Hopefully my talking and explanation will give you maybe a little bit of time to catch up as well if you're following along with me. And at this point, we know that this whole part is 3 inches on center of the hole in terms of width, but on center of the hole if you're looking at the handout. The problem with this is it doesn't add in the radial values, which if you look, it says radius or R, 3/4 of an inch on the right-hand side. So we have to add that into it. And we also, in terms of depth of the part, how far it goes back, that is actually explicit. That's 2.5, and that's stated. So let's just do what's known first. So what I'm going to do is click the line tool. Oops, I didn't mean to click revolve. I'm going to go back to sketch, sorry. The line tool, and just draw a horizontal line above. And these are going to be solid lines, right? And then also a horizontal line below, right? Those are our front and back of the part, essence, right? And they are 2.5 inches apart from each other, right? So we know we can do that. So one horizontal to the other by pressing D or the dimension tool. And I'm just going to put in 2.5. The problem is it's not on center, right? It's just randomly where I drew it. So half of 2.5 right? It's 1 1/4. Now it positioned those parallel lines equally spaced in reference to the center construction line. That's going to make up the flats on the switch. I'm sorry, I keep calling it switch bracket, but the fastener bracket. And at that point, I know I have circles, right? If you look down at the top view of this, there are circles, and we know where they are placed in reference to the center of the part. And we know how big those circles are because it says drill 5/8, 2 holes. So that's what I'm going to do. Take my center point circle. You can press C on the keyboard and just click that construction line that's in the horizontal center and just draw a circle on of any size in any position as long as it's on that horizontal line, because we're going to regulate these. I actually made my left circle a little bit bigger just to prove that point, right? So at this point, they are 3 inches apart from each other. So from the center of the circle with the dimension tool to the center of the circle, right? I know they're 3 inches apart from each other. But just like before, they're not centered in relation to that origin. So just because those circles are the right distance apart from each other, they're not in the right space. They're, like I said, distanced apart from each other correctly, but they're in the wrong space. So I'm going to go origin. This one is a little harder to grab with the mouse. Origin to center, and half of 3 is 1.5. Now the holes are at least centered in the horizontal space. They are also the right distance away from each other. And the last thing I need to do is dimension them to be the right size, which would be 5/8. So it does get a little bit messy in terms of dimensions, but these are construction dimensions. These are not presentation drawings, right? They're not going out to people. This is you constructing it. So 5/8, if you don't know the 0.625, you can get that. And then you have to do the other one too. It's getting a little crowded in the up, so I'm going to do it below, 0.625. Now those holes are the same size. They're in the right position. They're where they need to be. I could see some people right now early on, the big curved outside parts of the drawing or the model where it says radius 3/4. If you were to double 3/4, or if you had 75 cents in one pocket and 75 cents in the other pocket, you have $1.50 in total, right? So this outward arc where it's kind of where my mouse is going back and forth, that's annotated as radius because it's not a full circle. If it was a full circle, it would either say drill or diameter. Just because it's not a full circle doesn't mean it needs to not be one when we're creating it. We can create it using a full circle. And since it's a radius value, we can double it and make our diameter for our circle. So I'm going to press C on the keyboard, and since the radius and the diameter are concentric with each other, meaning they share the same center point, that's the center of this circle. So I'm just going to click it and make a bigger circle, and I'm going to do the same thing on the other side. It's going to look like owl eyes staring at you. Okay, so at this point we know they're supposed to be 1.5 inches in diameter because the radius is 3/4. It says it on the paper. So I'm going to press D. We already have the position because the centers of those other circles were already established. So 1.5. And I'm going to do the same thing on this side. I'm just going to go up because it's getting a little messy. 1.5. So now we have the, basically more than the arcs, but we have the arcs. And we have the circles that are going to be the holes. So when we extrude this bottom plate, the holes will already be in it. We're not going to have to do any cutting or anything. We're doing most of the sketch work that the model is going to dictate for us to do in terms of labor. So at this point, we need to know where that angled line is going to come and touch the edge of the circle to make the tangent connection, right? That smooth transition off that curve into the flat section. We know we have the middle of the part here, but we need to figure out where the edge is, okay? So once again, there's that radial value, 5/8. That's the radius, okay? So we can show an improper fraction. We can double that. We could just say 10/8, right? And it would figure that out. So if you're having trouble with your fractions and your decimals, this will equalize that, okay? So I'm going to use some straight lines instead of curves, but it's the same process. So I'm going to press L and create a straight line here. I'm going to press L and make a straight line here. I'm going to trim it, of course, but those are bigger than I need. That's okay. All right, and I know once again they are supposed to be 5/8 from each other. Okay, and I could have done this with a little bit more efficiency, and actually I'm going to do that. So I'm going to actually take the tip of this line and drag it all the way to the other side of the part, and take that and drag it all the way down too. So they're longer. Why? Because there's two sides to this. If you didn't do that, you're going to have to do it twice at the bottom, right? So I'm going to make it twice as long. These are going to be construction lines at the moment. So we're going to right click on these long lines we just made and turn them to construction. They're going to be dot dashed lines. They're guidelines. We need to know where the intersection is going to be to draw this angle line on both sides of the part, the front and the back. So at this point, since we have the radius value, we could once again do 10/8 in terms for the diameter, but we don't really need to because we're dealing with halves. So I'm going to press D on the keyboard, and I'm going to click the vertical construction line. I don't care which one of the two, and then the center horizontal or center vertical line, and I'm just going to put 5/8 or 0.625. That's positioned where it needs to be, and I'm going to do the opposite on the other side. 0.625. All right, now those lines are important. They're marking an intersection right here, right, where I'm going to draw an angled line down to the circle. The cool part about tangency with Onshape is it's going to automatically give you an indicator. You're going to see that tangent symbol pop up before you commit to clicking, so you'll know where it needs to be. So I'm going to press L on my keyboard and find the intersection between these two lines. You'll see almost like two perpendicular line symbols that pop up. That indicates you're actually on the intersection. So I'm going to click once, single click and release, right? And I'm just going to walk my mouse over to the edge approximately. You'll see a perpendicular symbol and a tangency symbol. The number is going to be 1.329. It'll always be that number. That's the known value for this. Everyone here in the whole class and anybody following online and in the future will also have this number as well, right? So that's one of them. I'm going to press L. I'm going to do the other three. It's the same operation. And sometimes you may not get it, so you have to like move that point up and down. There's a large snap to this. So as long as you see that 1.329 and the tangency symbol, you know you got it. So press escape, do it again, start at the intersection, find yourself a tangent point that says 1.329. And once again, this is a 4 times repeated operation. So like I say, got kind of messy. There's a lot of technicality here, right? Don't be intimidated by it, okay? Just try to focus on what you're doing and not all of the other stuff that could be confusing you or getting in the way. All right, so we have pretty much everything we need. We just have to trim. Trim ends with the letter M, and that's the shortcut on the keyboard. So if you press M, or if you click right here, at the intersection, Onshape will delete things. So if I put my mouse over here, I'll check you in a minute. Okay. If you click over here, I'll kind of delete the line segment. Now, some dimensions may go away because you're removing the geometry that the dimensions were tied to. So if that's the case, we could probably put them back by measuring and placing them again. But if they're construction lines, you can leave them. So I'm going to get rid of the long tails that stick off the edge. Since the rest is construction, I'm going to kind of leave those, but the semicircles, or the circles, are going to be semicircles, if you can see. So you just kind of click on the inner large circles, and they go away. And now you're left with 2 circles, and in that, like, you know, kind of rhombus-shaped object, right, the plate. That's everything. We've done it, right? We haven't done the vertical tabs, and that's actually easy. This is the majority of the work, the majority of the thinking. But you've seen that I've divided halves. I've took advantage of radius. I used trim. And at this point, I just need to know how thick this is, and it clearly says vertically it's a 1/2 inch thick. So I'm just going to say, okay, I'm done with my sketch. Right? My sketch is now completed. I'm going to click extrude. It's going to say what, and I'm going to click sketch 1. And then I'm going to put in my 1/2 inch measurement. And at this point, press enter, you have the majority of your plate. Now I also want you to take notice. You know where these rectangular tabs are going to come. They're going to be from that point to this point, right? So the rectangular tabs are going to come off of already known existing locations on our model. So at this point, all I have to do is snap a rectangle to these 2 points and specify the depth of it, which happens to be a 1/2 inch thick, right? And then go up the right height. The right height is something of an interesting mix, because if you look at the document, the height of the part is referenced from the very bottom to the middle of the circle. Then we still have another 5/8 of material or space to go that's not included. So we really have to take 1 3/8 for the height, subtract a 1/2 inch from it, and add 5/8 to it. So we're going to use the expression line in Onshape to put this in so it's easy for us. And I'll obviously put this into the video, and you can just copy along with me if you don't fully get it at this point, because once you see me do it, you will. Okay? So what I want to do is create another sketch, but on the top of this plate. So I'm just going to click the top of the plate. Now I have a sketch plane. I'm going to look right down at the top of it again like we were doing before, except now I'm a 1/2 inch above my top. I'm going to grab my 2-point rectangle, and I'm going to snap to one of them by clicking and releasing the intersection. I'm going to put my mouse over to the other. I'm not going to click. I'm just going to hover it there. So now the computer knows that I want it, and if I bring my mouse down slowly, you'll see the like orange and blue dotted line. That means that like I'm still snapped to both points. And if I click, I have my 1 1/4 inch that I didn't know what it was until it figured it out for me. So I'm going to do it again. Click and release at one point, bring my mouse over to the other point, just hover for a minute, and then walk your way up. It'll stay attached, okay? Only thing I need to do is dimension that this line and this line is a 1/2 inch, and we extrude it up, okay? And we're just about done. We're going to make use of a fillet, which rounds sharp corners, okay? So I'm going to press D. We're going to do 0.625. Oh, I'm sorry, not 0.625, 0.5. All right, there's our 1/2 inch. I'm going to do the same thing on the other side. We could have done 1/2 the geometry and mirrored it. Could have done it that way as well, but I don't want to get too deep into that. So at this point, I have my footprint for my little tabs. There was no other fancy dimensions for this, and I'm just going to say OK. And at this point, take my sketch 2 and extrude it. And here's where basically the larger mathematic expression comes in. I know that the whole thing is 1 3/8. So how do we put 1 3/8 in Onshape? 1 plus parentheses 3/8. Okay, so the whole thing is 1 3/8. But what I do need to do is I need to subtract 1/2 inch. So minus, in parentheses, 1/2. Now that 1 3/8 height is from the center of that hole on the vertical hole, and the radius out to the very top is 5/8. So I need to add 5/8 to this. So I'm going to hit plus, and I'm going to do 5/8. And I'm just going to wrap this in a final parentheses on the outer and the inner. Okay, so really I have 1 3/8 minus a 1/2 inch plus 5/8. When I press enter, that's my right height. Say OK. Now what I want to do is I know there's no holes yet. We're going to imagine the holes are there last. We're going to do the holes last. So I have sharp corners, and fillets will take a sharp corner and round it. Like if I gave you a piece of sandpaper, and if you had a controlled way, you can round it to whatever radius you wanted until the material went away. So that fillet tool is right here, and it's triggered with a Shift F. Shift F as in Frank. Okay, so we're going to click that. And then I'm just going to click each edge, all 4 of them at once. All right, so now I have 4. That's not rounded enough. But it told you the radius value is 5/8. So if I go to my radius value and type in 0.625, you can see that it lines up perfectly, because on center, right, the radius value should have worked based on our previous measurements. I say OK. The only thing I have to do now is put a hole that's concentric to this arc, right? That shares the same center point that's invisible right now. And that is done with a simple sketch on one of the sides. Doesn't matter which one you do. Center circle. Now we're going to hover our mouse over the edge of the arc. And at that point, I'm going to move my mouse vertically down, slowly, and you should see a concentric symbol pop up. No need to do any special measurements. Click and drag, or click and release. Now we're going to dimension this part. And that hole, I believe, was, as you can see, 1/2 inch, drill 2 holes, so 0.5. I only have to do this once. We're going to go all the way through this part. So when I say OK, sketch 3 is going to be my driller, if you want to call it that. We're going to extrude as a remove. And then we're going to drop down the blind option, and we're going to switch to through all. 1, it's going to go through the whole part. 2, in the future, if we are ever to change this, the holes will always go through no matter what we change it to. So I'm going to say OK. And at this point, the model is done. Okay. So I've spent, I don't know how many minutes doing this, but a handful. And at this point, I think it's fully captured, 20 minutes, a little longer than I expected. But I'm gonna get individual questions in a minute once I stop the stream. But once again, this will be detailed and documented for you to watch at any time. Okay, so hopefully you're able to do this. But looking over the shoulders of a lot, it looks like most of you kind of got a certain point, and then we'll take care of issues that you might have kind of jumped off pace, right? But for those of you that finished it, excellent job. But don't feel bad if you haven't, right? I realize one little mistake could set you off. So I'm going to end the stream now, and if you have any comments or questions, you can put them in the comments below if you're online. And